Hey guys. Okay, so now we're going to go over 1.4 property of exponents. And the exponents, if you don't know what the exponents are, but you should, it's when you have that little number up there. And what the exponents say is you take this number and you multiply it this many times. So 2 times 2, or 3 cubed is 3 times 3 times 3. Just as to briefly remind you what exponents actually do, what they are. But there are rules to using exponents, and so we're going to go over what these rules are. We call them the properties of exponents. So first property that we have are the zero exponents. So this property says for any non-zero number a, so a is a non-zero number, so anything but zero pretty much. For anything not zero, if you have an exponent that is zero, it equals 1. All the time, every time. And the power of 0 raised to the 0 is undefined. So this really means nothing, has no definition. It means nothing. So let's go ahead and write this out. A to the 0 is equal to 1 when a does not equal 0. Okay? So I have some examples on the second page that I want you guys to cover with me. So right here, in this first example, 3 to the 0. Well, 3 is non-zero, and the exponent is 0, so it just equals 1. And that goes for number 2 as well. Negative 2 is still a non-zero number. So if it's raised to the power of 0, then it's equal to 1. Anything raised to the power 0 is 1. Alright. Next rule that we have, property, is the negative exponent. So for any integer n, so any integer, so that's 1, 2, -1, -2, something like, like that. For any integer n and any non-zero number a, so again, a is still a non-zero number, then a to the n is the reciprocal of a to the negative n is the reciprocal of a to the n. So reciprocal, this is reciprocal. So if you have 1/2, or let's just say 2, sorry. If you have the number 2, the reciprocal of 2 is 1/2. If you have 3, the reciprocal of 3 is 1/3. And likewise, if you have like 1/3, the reciprocal of 1/3 is 3. Or if you have 1/2, the reciprocal of 1/2 is 2. So that's what reciprocal means. So what this is saying is a to the negative n is equal to, is the reciprocal, which is 1/a to the n. Just like that. So let's go down here to our examples again. So for number 3, we have a negative exponent. And so the negative exponent rule says that this is equal to its reciprocal. So 1/3 to the 4. Another way of looking at this, which is easier for me, it's not really scientific or technical or anything, but I look at it like this. So if you have, imagine this is being divided by 1. So what this is saying is that you can move this right here to the denominator, and it makes the exponent positive. Yeah? So let's go over 4 right here. So this is -4 to the -3. So if you imagine that it's being divided by 1, well, if we move that to the bottom, it then becomes positive. So we have -4 cubed. So now our exponent is positive. So let's look at 6 for a second, because we have a negative in both of them, right? So we have a -3 to the -2 and a 2 to the -3. So we can move this to the bottom and move this to the top, which is basically just using the reciprocal, the negative exponent rule, if we do that, we make the exponents positive. So then we move this to the top. So we have 2 cubed over, negative 3 to the negative 3 squared. Just like that. You can go over some of the rest of these whenever you're going through, if you want more practice, but I'm probably just going to leave it like that. If you were evaluating these expressions, like it says to do, you would actually be writing out what these equal. So this would be equal 1 over 81. And then this would be equal to, and you'd write what that is equal to, right? So make sure you're evaluating them fully. So just be aware that whenever you move these around, this isn't being made positive, it's the exponent that is being made positive. Okay, so we've covered 0 exponents and negative exponents. Okay, and then again, a does not equal 0. Okay, now we're going to go over the product of powers. So it says if the bases are the same, then add the exponents. The basis is referring to this number right here, the a number. So it's saying if they're the same and there are two numbers that are being multiplied by each other and they have exponents, then you can add the exponents if the base is the same. So if we had a raised to the m and it's being multiplied, that's what it means by product. Product is multiply. A to the n, so product of powers being multiplied together, then you can add the exponents and keep the base. Just like that. So a to the m times a to the n is equal to a to the m plus n. It's the same. So let's see if we can find an example down here. Okay, let's go with this one right here, number 17. Product of powers. So you can see here that our base is the same. Negative 5 is our base, but you can see here that we have they have two exponents right there. So this is saying that we can add the exponents and keep the base, and it's still equal to each other. So this is going to be 3 plus 3, which would be equal to negative 5 to the 6. Just like that. Now let me show you another way of looking at it. So for example, let's say we had 2 squared times by 2 cubed. Well, by this rule, this is equal to 2 raised to the 2 plus 3, which is 2 to the 5, right? Well, let's go ahead and break this down right here. 2 squared is 2 times 2, right? And this is saying that you multiply 2 cubed, and 2 cubed is 2 times 2 times 2. So this right here is 2 being multiplied 5 times. So this is equal to 2 to the 5. So you can see that we have the same answer right here. That's technically what we're doing, but we have a rule that says, hey, you can just add the exponents and it's the same thing if the bases are the same. Alright, now for quotient. So product was a division, or was a multiplication. Quotient is a division. So it's saying it's the same thing, but in division you subtract the exponents. So instead of multiplying, if we divide, you subtract the exponents. Just like that. And there are a couple problems down here that we can do. So number 15, let's go ahead and do that. Number 15 says 3 to the 5 divided by 3 cubed. Well, the base is the same. Our base is 3. So we can subtract the exponents. 3 squared. Again, I'm going to show you what we're technically doing. So 3 to the 5. 3 to the 5 divided by 3, what was it? 3 cubed. Let's go ahead and write this out fully. Let's expand our exponents. So this is equal to 3 times 3 times 3. So 3 multiplied by itself 5 times, right? And the denominator is 3 multiplied by itself 3 times. Well, using the rules of our properties of just multiplication and division, we can cancel out these 3's, right? So we can cancel out those 2 and those 2 and those 2. And we're just left with, right here, 3 squared, which was what we had down there. 3 to the 5 over 3 cubed is equal to 3 to the 5 minus 3, which is equal to 3 squared, and you can see that they're equal. So that's just so the quotient that's kind of just an explanation of what's actually happening if we were to expand our exponents. Okay. There's another one right here that you can try on your own. Again, the bases are the same, but you just have to subtract the exponents there. Now, power of a power. So this says to find a power of a power, you multiply the exponents. So the power of a power will look like this: a to the m raised to the n. So you see that we have a power, but then outside of that power is another power. So it's saying here you just have to multiply the exponents. Just like that. Okay, let's see if we can find one down here that looks like that. So number 18. So we have a q to the 5 to the 3. So this is saying that we can just multiply the exponents and get the right answer. So this would be q to the 15. So let me break this down again like we did with the other ones. So what we're saying here is that we're multiplying q to the 5 3 times. So q to the 5 times by q to the 5 times by q to the 5. Again, that's being multiplied 3 times. This is equal to this right here. Okay, now again, if we use our product rule, we have the base of q and they're all the same. So this is q to the 5 plus 5 plus 5, which is equal to q to the 15. So you can see that we're just expanding on our rules that we have and using them together. Does that make? I hope that makes sense, but if not, just let me know in class if we could go over a couple more examples. But here's another example you can try on your own, number 19, and use that same rule, and hopefully you can see the relationship that they have together. Okay, now a power of a product. So this is saying AB raised to the m. So to find the power of a product, so right here our product is A times B, and it has a power of m right there, a power of a product. So it says find the power of each factor and multiply. So it's saying that we have to find the power of each factor and we multiply them together. So this is equal to A to the m times B to the m. So this is the technical way of saying it. If I'm gonna just kind of dumb it down a little bit so that it actually makes a little bit more sense, what you're basically doing is it's not technically what you're doing, but that m is kind of being distributed to each factor inside that parenthesis. So you have A to the m times B to the m. This is being multiplied right there. So that's power of a product. And now let's go ahead and see if we can find one down here like that. So number 21. So we have two factors, negative 4 and d, right? So what this is saying is that you find the power of each factor and multiply them together. So the power of negative 4 to the 4 multiplied by d raised to the 4. Just like that. And you can find what this is, you can evaluate that, but to save time, I'm just gonna keep going. Let's do the same for number 22. So we find the power, we have two factors, negative 3 and f, and we find the power of both of them, and we multiply them. Just like that. They'll be equal to each other, so this is equal to that right there. Alright, so that's the power product, and now we have the power of quotient. So again, multiplication, but now we're going to have division between the two. So it's saying it's the same thing. So if we have a divided by b, and that's being raised to the power of m, that's going to be a to the m over b to the m. And we can see that right here in 23. So we just have to find the power of the denominator and numerator and the denominator. So this is equal to 4 to the negative 3 divided by x to the negative 3. That's pretty much it. So we have covered every property of exponents that we're going to use for this section. So you can go back through all of these exercises and do them yourself. I encourage you to do that for more practice. Just to let you know, so again for this one you're going to evaluate the expression, so evaluate it fully, and then in exercises 9 through 23 you're supposed to write your answer using only positive exponents. So let me go through a couple of these because this is what your homework is going to look like. I'll go over 14 since it's a little bit more technical, but we're going to be using a couple of our properties in this one to solve this. So right here we have 2 to the 3. We can solve for that one instantly, right? 2 to the 3 is 8. Then we have a to the negative 3, and we don't want any negative exponents. But from the negative exponent property, again, if we find its reciprocal, we can move that to the denominator and make the exponent positive. So if we move that down here, it's going to be positive, so a cubed. We're just going to go term by term by term, okay? So here we have another negative exponent, right? So let's go ahead and move that up. So then we have times by 8 to the power 1. Okay? We have another negative exponent here. We can move up to the numerator, and our exponent's positive. And then this is raised to the power 0, so that's equal to 1. Now, this is 8 to the power 1, right? So 8 times 8, that's just 8 squared. And so that means it's like 64, I believe. So this is equal to 64 b to the 5th over a cubed. So that is simplified as much as we can. So that was our goal, to simplify using only positive exponents. So you can go ahead and go through these other ones. They're more simpler than that. So go ahead and give that a shot. I'm just going to go over 2 story problems that you should expect to see on the homework. So you can use this as a guide. So for this story problem, we have a cylinder right here, very poorly drawn by me, and it says that it has a radius of h over 2. So this is the radius. And it wants to know what the volume is. Well, the volume of a cylinder, I'm going to write that down. Volume is equal to pi r squared h. H being the height, So we have our volume equation, so now we have to find the volume. So it says here, however, that our radius is h over 2. So right here, we can plug that in right there. We can substitute h over 2 in. So v is equal to pi times by h over 2 squared times by h. And now we know a property of an exponent that will help us solve this right there. And that would be the power of a quotient, right? Power of a quotient. So we can distribute that, and we could solve for our volume. So our volume is equal to pi times h squared over 2 squared times by h. Now let's simplify. So this is equal to pi times by h squared over 4 times by h. Simplify it a little bit more because we can multiply these together because they're like terms. So we have pi h cubed divided by 4. So there should be something like that in your homework. So the goal is to use an equation like this, our volume, and then plug in the variable that it gives us, substitute it in, and then simplify using property of exponents. So I know we're going pretty quick, but I want to make this video short. So for our last example, this is from number 6 in the book. So it says a jellyfish emits about 1.25 times by 10 to the 8 particles of light. So 1.25 times 10 to the 8 particles of light, or photons, in 6.25 10 raised to the negative 4 per second. So we're saying per 6.25 times 10 to the negative 4 seconds. So that's how we write it. It's kind of like miles per hour, but we're saying light, particles of light per second. So it wants to know how much it emits per second. So again, how many does it emit for how many photons does a jellyfish emit each second? So per. Then write the answer in scientific notation and standard form. So here, if we just break this down right here, we have a quotient and we have exponent. So now we just have to use our exponent properties that we have. So we have 1.25. I'm going to break this down even more. Divided by 6.25 times by 10 to the 8 divided by 10 to the negative 4. Right here, we have a negative exponent, right? So let's make that positive. So 1.25 divided by 6.25 times by 10 to the 8, and we're going to move that up there to be 10 to the 4. Just like that. Okay, we can simplify that even further. 1.25, 6.25 times by 10 to the 8, and then if we use the power, the product of powers right there, we can add the exponents there. So that's 10 to the 12, right? And then if we do this right here, that's going to be 0.2 times 10 to the 12. Now, depending on who's doing the grading and what the book wants whenever you're doing your homework, it might want this as not as a decimal. So basically we can just write this as 2 times 10 to the 11, because if we take one of these 10s right here and we multiply it by this 0.2, it's going to make it 2, but then we have one less 10 right there. So hopefully that makes sense. But for me, if it's ever on something that I write, I'm fine with either way. But basically right here, this is your scientific notation. This is your scientific notation. So if we want to write that out, it says how many photons does the jellyfish emit each second? It emits 2 times 10 to the 11 photons each second. And if we want to write it in standard form, we just have to write that out. So that's 2, that's 11 zeros. So it's 2 0 0 0 0 0 0. So I think that's 11. 1, 2, 3. Nope. I think we need one more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There you go. So this is standard form. Alright. So there's going to be something like that in your book as well. So it might be a little bit different, but the overall gist is that it's going to give you two numbers like this. And basically you're going to have to use your property of exponents to figure out your answer. So just like what we've been doing. Alright, email me any questions, come to class with questions, and I'll see you in class. Thanks, guys.